आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. We welcome Dr. Arup Ranjan Mukhopadhyay from Indian Statistical Institute. He shares about his vast experience and achievements in the field of quality, reliability and operations research.
I am working in the SQC and Word Division, particularly in the SQC and Word Unit, Kolkata, Indian Statistical Institute. For the last maybe 32 years, I am working here. More than that, I think 34 years I am working here. So my area of work is essentially quality, reliability and operations research. And at present, I am working on Six Sigma and statistical quality control, and there are other quality management methodologies. So I am working on that.
In this episode, Sir talks about the research endeavor of him and his team in the field of statistical quality control.
Today, I want to talk about statistical quality control, the kind of work what I am doing along with my research scholars. So essentially about statistical process control. So that is my topic. To tell you very specifically, it is about the control chart. Control chart is essentially if you consider a process characteristic and that you are plotting over time and you want to see whether the process is remaining under stable condition or not. So stable condition means that suppose there is some limit, we call control limits. You can say Lakshman Rekha, whether those points are crossing those limits or not. If they are remaining within those limits, upper and lower limits, and they are fluctuating around the mean in a random manner, then we say it is a stable process. If no non-random pattern of variation is there in the behavior of the points, so it is fine, we will be satisfied. But if there is a sudden jolt in the process, sudden disturbance in the process, we call it assignable cause of variation or special cause of variation, because of which a particular point may cross the limit. So that time we say it is under the influence of assignable cause of variation. It requires investigation so that one can unearth the cause and one can improve the process. Why is it necessary? If we do not take action against the assignable cause, when it is identified, then one will be having unstable condition of the process, and under the unstable condition of the process, one will be producing non-conforming products. So non-conforming products will be reaching the hands of it may reach the hands of the customer also. So there will be two kinds of losses. One is called the internal losses, internal failures. So rework, scrap, these are the examples of the internal failures. And there may be external failures when it will be reaching the hands of the customer. So then it has to be repaired or it has to be replaced. So that has its cost, and particularly if it is coming under the warranty, product warranty. So that cost has to be borne by the organization. And there are some secondary effects also. Suppose the customer is so dissatisfied that he is switching over to another organization for purchasing that kind of product. So in that case, the reputation loss or goodwill loss will be there, which will be really very big amount of loss. So in order to prevent these kinds of losses, we'll have to ensure that the process remains under the stable condition. And if it remains stable, then what is happening? We can go for the capability assessment of the process also. So that means process characteristics, etc. Now, thing is, there are three important. So actually, I am working on design of the control chart. Design of the control chart means, so how frequently will you take the sample? So what will be the sample size? Second question. Third is, say, what will be the control limit? We say multiplier of the control limit. So how much will it be? So these are the three crucial important questions. That's how we design the control chart. Traditionally, these answers have been given through statistically. Statistically means there is a concept called rational subgrouping. Rational subgrouping means if you think that in your process assignable causes of variation are present, then you should take the samples in such a manner that the between sample, the time interval between samples will be maximum, because you want to catch the shift in the process over the time period. But within sample variation should be as minimum as possible. And based on the within sample variation, we will be deciding the control limits, etc. So it is a statistical way of determining these three questions, that answer to these three questions: the sample size, sampling interval, and the control limit multiplier. But we are doing in a different manner. We are considering economically, from economic consideration, how to answer these questions: the sample size, sampling frequency, and the control limit multiplier. So basically, when you will be taking the sample, then there is a cost involved in it. Cost of testing, cost of sampling. That cost is there. Then if you'll have to discover the assignable cause. Okay, that means out of control signal, you'll have to discover when it is giving. And possibly you'll have to take the corrective measure with respect to that particular assignable cause. It has got its cost. Number two. Number three is, if you cannot detect the assignable cause, then what will be the consequence? The non-conforming product will be produced. So internal failure will be increased. It may be, if it goes to the hands of the customer, then external failures will also be there, as I told you earlier. So that is the thing. So these are the costs. So cost of testing and sampling, cost of finding the assignable cause and correcting it, and cost of producing non-conforming products. Okay, now these costs, what is happening actually, if you increase the testing and sampling, maybe you can detect the assignable cause faster. But what will be happening actually, then the overall cost will be increasing. So what will be the exactly, so cost function has to be made, and you'll have to optimize this. You'll have to find out N, the sample size N. I am saying sampling interval H, say H star, N star, and then, control limit multiplier I am calling K star. So N star, H star, K star we want to find out based on optimizing this particular cost function. Some works have been done previously by other people, Duncan and all that. But there are some lacuna with respect to determination of this sample size, because sample size is basically not a continuous random variable. It is an integer kind of random variable. So the way he treated that, That is not the exact way. So we are doing it in a different manner. So that is the thing, that kind of work we are doing. So it is called algorithmic approach. So that is the thing we are doing. Algorithmic approach, partial derivative and algorithmic approach, repetitive algorithmic approach. And so that's how we are doing the things. In a nutshell, that is the thing. It has got wide applications in industries. Say, for example, if you consider a steel industry, okay, this metal chemistry is very important. The carbon percentage, silicon percentage, manganese percentage, sulfur, phosphorus, titanium, all these chemicals are very important. So let us say carbon percentage in steel. So it has got its upper limit and lower limit. It should be fluctuating within that. If it does not, that means if the carbon percentage is more, then it will be causing brittleness in the product. Suppose if you consider the rail line, okay, that rail line, what we are making. So if it becomes brittle, it will be disastrous for the operation. So that is the thing. So at the same time, it should not be low also. If it is too low, then what will be happening? The strength of the metal composition will be less. So strength is also very important. So it cannot be very high, it cannot be very low. So it requires a lot of attention on the part of the industrial engineer. So that is the kind of thing we are doing. So a similar thing I can give you another example, more catchy example. Say in case of healthcare, if you consider child mortality rate in a hospital. So child mortality rate, of course, it is lower the better kind of characteristic, and if it is 0, we'll be very satisfied. Always it cannot be achieved. Now, suppose you are plotting that child mortality rate. Okay, that is the quality characteristic as I talk to you. Now, child mortality, suddenly you are getting a spike. Okay, that is due to some assignable cause. It has got a tendency to remain within certain limits. It is fluctuating randomly within certain limits. But suddenly you are finding, if you plot over the time, the child mortality rate is spike. Why is it happening? There must be some assignable cause. So this particular procedure will be giving you that signal when the action needs to be taken. And what kind of action, that is to be found based on process knowledge. And in order to do it properly, answer to these 3 questions: what will be the sample size, how much will be the sampling interval, and how much will be the control limit exactly. Popularly, it is called Shewhart control chart. 3 sigma control limit, that means control limit multiplier will be 3. That's what has been advocated by Shewhart, but it may not be always 3. Through optimization techniques, we may land up with another value of K, and that will be more scientific. So that is in a nutshell the kind of work we are doing actually.
We feel enriched to listen to Professor in this episode where he shares about his research.